So I'm going to go through some more problems in your book. So the directions for problems 7 through 18 are given right here, and we're going to focus on number 10. So on number 10, they tell me that the tangent of an angle is equal to 1/2, and then they're telling me that that angle is between pi and 3 pi over 2. So my reference triangle is right here in quadrant 3. So this would have to be a -1 and a -2. And using the Pythagorean theorem, this is going to give you the square root of 5. So I now know that the sine of that same angle is -2 over the square root of 5, and the cosine of that same angle is -1 over the square root of 5. They want me to find the sine of 2 theta. So the double angle identity I can apply. I'm going to replace both of those with the ratios I just found. So it's going to be 2, and then it's going to be -2 over the square root of 5, -1 over the square root of 5. So it actually gives me -4/5 for the sine of twice the angle. So the cosine of twice the angle will be cosine squared theta minus sine squared theta. I'm going to plug in these ratios again. So cosine was -1 square root of 5, sine was -2 square root of 5. So I end up with 1/5 minus 4/5, which gives me -3/5. And then if I want to know the tangent of twice the angle, I already know the sine and the cosine, so I don't need any other formulas. I'm just going to use my quotient identity, and I'm going to plug in my values. And then I end up with, and actually this was a positive right here, -4/3. Now they want some half angles, and I'll just go through and I'll do one of these for the half angles. So let me clear some space. And I can do either the sine or the cosine. Let's do the cosine of half that angle will be plus or minus the square root of 1/2 1 plus cosine theta. So I already know cosine theta, and I can even plug that in if I want to. Cosine theta is -1 over the square root of 5. The problem is with the plus or minus sign. So if you look at your original angle, it was between pi and 3 pi over 2. So I don't know whether to use a plus or minus. I'm going to have to first divide everything by 1/2 to figure out the restriction here. So for my half angle. And I didn't have to do that for the double angle because there wasn't a plus or minus in the formula. So when I'm looking here, that restriction actually puts me in quadrant 2, so I have to pick the negative. So I have negative now, and I've got 1/2 minus 1 over 2 square root of 5, and then to rationalize this it's going to take quite a while. I need a common denominator first. So in my math lab, if you get that far and you don't want to rationalize, I completely understand. Just hit the show my instructor, ask my instructor, and I can look over your work. So when I'm looking here, the first thing I'm going to have to do on the inside is multiply top and bottom by the square root of 5. So then I'm going to be left with negative, and I've got to go back to make sure I've got that right. So square root of 5 minus 1 times the square root of 5. And then I've got basically 2 times 5 now, so I've got 10. So then I'm left with negative, and then I've got 5 minus the square root of 5 over 10. And now you're still not rationalized, so you'd have to multiply top and bottom by square root of 10, square root of 10. So I now have negative, and I've got 5 minus the square root of 5, 10, because I brought that inside, over 100. So now you have 50 minus 10 square root of 5 over 10. So that took a lot of rationalizing on that particular problem. So if you wanted to, you could have gone back right here, and once you've gotten this far, you could have stopped. So that's using the half angle. The half angle, you have to be careful because you have to pick the plus or minus. That means that you've got to figure out the restrictions on which one to use there. Now the next one, 56, they want me to establish this identity. So they want me to show that the sine squared theta times the cosine squared theta equals that other side. So the first thing I'm noticing is I could use the two half angle identities. So I've got 1/2 1 minus cosine 2 theta, and then I've got 1/2 1 plus cosine 2 theta. So the half and the half is going to give me the fourth, and then I've got 1 minus cosine 2 theta, 1 plus cosine 2 theta. Now you're going to FOIL that out, and when you FOIL that out, you're going to be left with 1 minus cosine squared of 2 theta. And when you're looking at that, that's not exactly what they want. So I could go through and notice that that is also the double angle formula again. So I've got the 1/4, the 1 minus, and so that's going to be 1/2 1 plus cosine now of 4 theta. So when I look at that, I've got 1/4, I've got 1 minus 1/2 minus 1/2 cosine 4 theta. So I have 1/4 1/2 minus 1/2 cosine 4 theta, and now I could factor out a 1/2, so a half and a fourth is an eighth, and I end up with what they wanted me to prove. So I started with the left hand side, worked my way to the right hand side. So that's 56. Now let's look at 86. 86 wants me to find the cosine of twice the inverse tangent of -4/3. So I've got to remember and let my angle be the inverse tangent of -4/3. So they're basically right here asking me for the cosine of twice an angle. And the cosine of twice an angle, I've got several different double angle formulas there I could do. I could say, well, that's sine squared theta minus sine squared theta. That would be one. Or I could do one of the other two. So I'm going to come here and draw a reference triangle. Now the inverse tangent is defined in between -90 and 90 degrees, or -pi/2 to pi/2. So this is going to be a -4, a +3, and then when you do the Pythagorean theorem, that's going to give you a 5. So I now know I can find these ratios. Looking here on the sine, the cosine of that same angle would be 3/5. The sine of that same angle would be -4/5. And again, this is an angle, and I call that angle theta. So I'm going to plug these in. So that's 3/5 and -4/5. So I have 9/25 minus 16/25. So I get -7/25. So that one, 86, was a hidden way to write an angle. So to recap what we've talked about in this lesson, we've done our double angle identities, our half angle identities, and some applications. Make sure you read through the next section as well.